This video will introduce you to problem solving in big circles. I think about big circles like a big puzzle with a whole bunch of different pieces that we have to put together. And once we put certain pieces together, they'll help us find others and put other pieces together. Now, the biggest piece of advice I can give you when working in the big circle is to label everything clearly. You're going to use arcs that they give you to label angles. And you might go backwards too and use any angle measures that they give to you to label arcs. But again, it's really going to simplify things if you get in good habits now and label everything you can label within the picture. All right, so in this problem, we're given circle O, which has no diameters. We're given a tangent to the circle at point A, and we're given that the ratios of the measures of these arcs are 3 to 3 to 4 to 5. I'm going to stick an X on each one of these, and then I'm going to go label them in the picture. So arc AB is represented by 3x, arc BC also by 3x, arc CD can be represented by 4x, and arc DA by 5x. And we know from our study of circles that we've done, we know that all together the sum of all the arcs in the circle have to total 360 degrees. So I'm simply going to go and write an equation that sums all of those arcs together, setting it equal to 360 degrees. And that makes the value of x 24. So this arc from D to A would be 5 times 24, or 120 degrees. The arc from A to B is 3 times 24, or 72 degrees. This arc is the same, 72 degrees. And the last arc is going to be 96 degrees. And now I'm going to go ahead and I'm going to start my work. So for the measure of angle 1, note the location of the vertex. It's on the circle. His degree measure is going to be equal to half of its arc. So for angle 1, the degree measure of the angle equals half of the arc. So the degree measure of angle 1 is going to be half of 96. Half of 96 makes the measure of angle 1 48 degrees. Notice that I'm going to label it in the picture because perhaps at some further point I can use that to help find the angles in the triangle, or I can use it to find linear pairs. There's probably a lot of use for a lot of other ways I can use that angle. Angle 2 has its vertex on the circle. His degree measure is going to be equal to half of the arc that he intercepts. So the measure of angle 2 now is going to be half of 72, making the degree measure of angle 2 36 degrees. And again, I'm going to label that nicely and neatly in my picture. Because now I can find angle 8 pretty easily by using the angles in the triangle. So angle 8 has to be 96. And the reason for that, triangles have to sum to 180. And if angle 8 is 96, then angle 6 also has to be 96 because he's vertical to angle 8. Notice that in the picture, angle 7 forms a linear pair with angle 6. That tells me with that his degree measure is going to have to be 84 degrees. And likewise, this other angle is going to have to be 86 degrees as well because he's vertical. So again, just by pulling that one angle out of the triangle, it actually gave me a whole bunch of different angles that I was looking to find, and I was able to skip and jump ahead by using the picture to find the measures of these angles at 6, at 7, and at 8. All right, I'm going to go back to angle 3 now. Angle 3 has his vertex on the circle. So for angle 3, the degree measure of angle 3, the angle is going to be equal to half of the arc that he intercepts. So the measure of angle 3 is going to be half of the 120, or in other words, 60 degrees. Angle 4 now is going to be fairly simple to find because I know that in the yellow triangle, the sum of the three angles have to total up to 180. So 180 minus 86 minus 60 tells me that the measure of angle 4 is now 36 degrees. And again, triangles sum to 180. Angle 5, I notice, happens to form a straight line with angle 4, and together they have to total up to 180. So 180 minus 36 gives me 144 degrees for angle 5. Wow, and we're doing really, really well here. Angle 9 has his vertex on the circle, so his degree measure is going to be half of the arc that he intercepts. And just be very, very, very careful when you're working with angle 9 because his arc is a little bit funky. If I go back and trace over the sides of angle 9, we're looking at the arc that lives here between C and all the way back up here at A. So we're looking at that whole arc that encompasses the 120 plus the 96. So the 120 plus the 96 is going to be half of 216, which makes the measure of angle 9 108 degrees. Angle 10, we could find a couple different ways, but I think the easiest way is to just look at the supplement to the 108, making the degree measure of angle 10 72 degrees. And then lastly, angle 11, I'm going to look at this large purple triangle, and in that large purple triangle, I know the sum of the angles has to be 180 degrees, making the measure of angle 11 12 degrees. Now, I could have also looked at my rule for the vertex being outside the circle, and that would have found the measure of that angle quite nicely as well. So it's important to notice that there are many of these angles that you might find by more than one method. All right, so that's what I have for you on the big circle. As always, thanks for taking the time to watch the video. See what you can do in solving the questions on the next page.